Okay, so you made it to problem 5. So in problem 5, what we're going to do is we're going to go ahead and practice the idea that we saw in this lesson so far. And mainly it's these two. The first is how do you find inverse equations, and how do you check to see if what you have is really the inverse. So the first step is to identify the operations in order. Okay, if you think of our analogies, in what order was this present wrapped? So if I look at this equation, f of x, the first operation that I can see is that it's being multiplied by 3. The second operation is that it's being subtracted by 6. So if I'm trying to undo or unwrap this present, I have to start with the last layer. So instead of subtracting 6, I'm going to add 6. Instead of multiplying by 3, I'm going to divide by 3. So then what I say is f inverse of x is equal to x plus 6, because that's my recipe says, and then I'm supposed to divide this by 3. This is what I claim is the inverse equation. Now to check, here's my check. In fact, let me use a different color here. So to check, I'm going to pick an input and plug that into the original function, f of x. Whatever comes out is now the input for f inverse of x. Okay, so let's pick some number here. And I like to pick numbers that are small and easy to work with, so I'll say x is 2. So if x is 2, I'll do a little mental math. 3 times 2 is 6, 6 minus 6 is 0. So the output is 0. So now the input for the next machine is 0. So 0 plus 6 is 6, 6 divided by 3, that's y equals 2. There we go, let me clean that up a little bit. So if you notice here, the final output is the original input. This is a check. This is how we know it's working, that we're thinking about it correctly. Okay, so this is how we find it, and that's how we check it. Okay, let's continue. Now let's look at B. So in problem B, I'm going to list out the operations first. So the first thing that's being performed on the input is it's being cubed. The second thing is that it's being subtracted by 5. So I'm going to undo all of that. And I'll start with whatever the last operation is. So in this case, it'll be adding 5. And then it'll be, instead of cubing it, I'll be cube rooting it. So then I would write down that the inverse, g inverse of x, is equal to the input plus 5 cube rooted. Okay, so there's my inverse. I'm going to go ahead and check it. So to check, I'm going to choose a value. This time I'll choose 1. And so I'll say 1 inside of, so g of 1 equals, let's see, 1 cubed is 1, 1 take away 5 is negative 4. Okay, so now what I'm going to do is I'm going to input negative 4. That's now the input of g of negative 1. I'm sorry, g inverse of x. So I'm going to say g inverse of negative 4 is equal to, let's see, negative 4 plus 5, that's 1. The cube root of 1 is 1. So notice how that takes me back. Perfect. Check. That works. Okay, that's B. Now, C, we have P of x. So the operations, okay. First, x is being added by 3. Next, x is being cubed, or that quantity is being cubed. And lastly, it's being multiplied by 2. So I'm going to go ahead and undo each of these operations, and being very careful to do them in reverse order. Okay, or undoing them in reverse order. So instead of multiplying by 2, I'm going to divide by 2. Instead of cubing, I'm going to cube root it. Instead of adding 3, I'll subtract 3. So then I'm going to write down that P inverse of x is equal to x divided by 2, cube rooted, subtracted by 3. To check, so here I go checking. I'm going to pick a value for x. I don't know, like, let's see, I'm going to pick 1. X equals 1. And that means P of 1 equals 1 plus 3 is 4. 4 cubed, let's see, that's 4 times 4 is 16, times 4 is 64. 64 times 2, that's 128. So the output is 128. So 128 is now the input for the next machine. So P inverse of 128, and I expect it to take me back to the original. So 128, let's see, half of 128 is 64. the cube root of 64. Let's see, cube root of 64. I just had it. I believe it's, let's see, here's a fast way to do it. Let me just check it really quick. I believe it's 4, but I don't want to make a mistake here. Yes, so it's 4. The cube root of 64 is 4. So that means this quantity here is 4. 4 take away 3, that's 1. There you go. So it took me right back to where I started. So that's verification that P inverse of X is correct. Okay. So in the last problem, I'm going to go ahead and list the operations. First thing, I'm going to subtract. The input is being subtracted by 4. It's being multiplied by 10. It's being divided by 3. Okay, that's what the function is doing. Now to undo it, to find the inverse equation, I'm going to go ahead and undo each of the operations, but in reverse order. So first thing I'm going to do is multiply by 3. I always start with the last operation. I'm going to divide by 10. I'm going to add 4. So that means the inverse function for t of x, t inverse of x, is equal to x times 3, divide by 10, add 4 more. So there's our function, and then I'm going to check it. So here's my check. And I'm going to choose x equals 2. So let's see, let me do some work ahead of time. No, I don't want, well, okay, I don't want the output to be a fraction, so I'm looking for numbers that avoid that. So let's see here really quick. It'd be nice if this top number was 30, so if this was a 3, okay, I'm going to choose the input is, let's see, 5, 4, 5, 6, 7. So 7. So if x is 7, okay, if my input is 7, then t of 7, hopefully that works. 7 take away 4 is 3. 3 times 10 is 30. 30 divided by 3 is 30 divided by 3 is 10. So that's my output. Now this output of 10 is now the input for the next machine. So I'm stacking them. So t inverse of x, t inverse of 10 is, so if I look at my red function here, 10 times 3 is 30. 30 divided by 10 is 3. 3 plus 4, that's 7. That takes me right back to where I started. So that's a check. And that's how you practice finding inverse equations and checking them.